There is a very specific, almost undeniable magic trick happening right in front of you every single time you look at a truly great architectural sketch.
Oh, absolutely. It's wild when you really think about it.
Right. I mean, you're looking at a completely flat piece of paper. Like maybe there's just some ink spread across the surface, maybe a few pencil smudges, but your brain just refuses to see a flat piece of paper.
It completely rebels against the reality of the paper.
Yes. Your brain sees a room you can step into, or it sees this massive skyscraper looming over you. It sees a space so real, so totally dimensional, that you might actually feel a twinge of vertigo just looking at it.
Yeah, that physical reaction is real.
It is. We're tearing apart the foundational text on architectural drawing, specifically looking at the systems of 1-point and 2-point perspective.
Which is such a massive topic.
It really is.
Yeah.
And our mission today is to figure out exactly how architects translate the massive three-dimensional world we live in onto a flat page, making buildings feel, totally inhabitable before a single brick is ever actually laid.
Because, I mean, imagine laying a blank piece of paper on your desk right now. You're armed with nothing but, like, a ruler and a pencil. To draw architecture on that paper is, well, it's essentially to draw space itself.
Right.
And perspective is the ultimate tool for understanding how human beings actually perceive the space around them. So whether you're an aspiring designer, a lover of architecture, or just, insanely curious about why a towering cathedral makes you feel tiny while a cozy coffee shop makes you feel secure, these rules we're looking at today govern all of it.
Definitely.
Yeah.
But before we can even attempt to build a world on a blank page, we need to understand the invisible rules that govern our own eyeballs.
Yeah, the biology of it almost.
Exactly. And the text highlights this massive historical shift. Like if you look at ancient or medieval art, the artists were just they were guessing at depth.
Right. It was very vibes-based.
Exactly. The person in the background was just drawn a bit smaller, or maybe placed higher up on the painting surface to suggest they were far away. It was totally intuitive, but it wasn't mathematically grounded at all. You couldn't use it to plan a building.
No, not at all. And that guesswork dominated for centuries until the Renaissance in Italy, which, I mean, this brings us to a foundational moment in human perception.
Oh, the Brunelleschi thing?
Yes, Filippo Brunelleschi. He was an architect, and he wanted a rational, measurable way to represent space. He didn't want to rely on feeling anymore, He wanted absolute proof.
Right.
So he conducted what is now famous as the mirror experiment at the Florence Baptistery. He basically painted a highly detailed, mathematically calculated picture of the baptistry on a wooden panel.
Okay, let's unpack this, because the mechanics of this experiment are completely mind-blowing.
They really are.
So he paints it, and then he drills a small hole right through the center of his painting, right? Like right at the vanishing point.
Exactly, right through the wood.
So he stands facing the actual physical building in Florence. He holds his painted panel up to his face, with the painted side facing away from him, and he peeks through the little hole he drilled.
Right, so his eye is directly on the vanishing point.
Yes. So he is looking at the real building through a hole in his painting.
And then this is the genius part. He takes a mirror and holds it out in front of the painting. Suddenly, instead of seeing the real building through the hole, the mirror reflects his painting back into his eye.
Oh, wow.
Yeah, by dropping the mirror and pulling it back up, he could instantly switch between looking at the real 3D building and looking at his flat 2D painting.
And it was a perfect match.
A perfect match. They aligned perfectly, the lines matched, the scale matched. He basically proved to the entire world that space could be measured, ordered, and visually controlled on a flat plane.
That is just, that mathematical breakthrough completely rewired how humans build. It meant that for the very first time, an architect could imagine a complex sequence of rooms, draw them, and guarantee exactly how deep and wide they would look to a person standing inside them.
It changed everything. It took it from an art to a science.
Right. And to pull off this system, the text outlines a few foundational building blocks. The first is the horizon line, which, I'll be honest, I always thought the horizon line was just the visible landscape, like where the ocean meets the sky.
A lot of people think that. But in architectural perspective, the horizon line is strictly defined as the exact eye level of the viewer. It has nothing to do with the earth and literally everything to do with your body.
Wait, really? So it moves with you?
Exactly. Everything in the drawing relates to it. If you were standing up, that horizon line is at your standing eye level, say, 5.5 feet off the ground. But if you sit down in a chair, your horizon line drops on the page. If you lie on the floor, it drops further. It is the literal physical level at which you are experiencing the world.
That makes so much sense. And sitting right on that horizon line is the second key element, the vanishing point. This is the spot where parallel lines appear to converge.
Right, the anchor.
Yeah, and the text explains that we basically need to formalize a visual glitch in how humans see. Think of a long, perfectly straight grocery store aisle.
Oh, that's a great example.
Right. The shelves on your left and right are perfectly parallel in physical reality. But as you stand there and look toward the dairy section at the very back of the store, those shelves seem to squeeze together, funneling your eyes to a single point in the distance.
And those converging lines, funneling your vision, they have a specific name in geometry. They're called orthogonals.
Orthogonals.
Yeah. These are the lines receding into space, just pulling away from you.
I like to think of orthogonals like the strings of a puppet. They literally tie the corners of the room directly to your eyeball.
Oh, I love that analogy.
Thanks. Yeah, if you pull on them, you pull the depth of the room closer to the horizon line, creating this mathematical grid that your brain just instantly interprets as three-dimensional distance.
Exactly.
So you have the horizon line setting your eye level, the vanishing point acting as the anchor, and the orthogonals acting as the puppet strings, pulling the space backward.
But having those mathematical strings is one thing, right? How an architect actually chooses to use them dictates the entire psychological experience of a room.
Right, the mood of the space.
Exactly. The text starts with the most direct, almost aggressive approach to guiding the human eye, which is one-point perspective. This system is deployed when one face of an object, or say the back wall of a room, is entirely parallel to you, the viewer. You are staring at it dead on.
So all the vertical lines of the wall stay perfectly vertical.
Yeah.
And all the horizontal lines of the floor and ceiling facing you stay flat and horizontal. But the depth, like the side walls, the floor tiles pulling away from you, all those orthogonal lines just get sucked into that single vanishing point on your horizon line.
Right. It is absolutely perfect for drawing corridors, long hallways, or, the classic example, staring down a church nave toward the altar.
Oh, sure.
And consider the psychological impact of that geometry. One-point perspective is deeply forceful. It dictates precession.
Precession.
Yeah, when we talk about precession in architecture, we're talking about that feeling of being physically pulled forward, like you are walking down the aisle at a wedding or approaching a throne, because every single receding line in the architecture converges to one dot. Your eye has no choice but to be drawn inward right down the center.
It creates this sense of profound stability and formality. But wait, let me push back on this a little bit.
Yeah.
If one-point perspective only works when I'm staring dead center at a back wall, what happens if I take 2 steps to the left? Or what if I just naturally wander through a room? The whole mathematical illusion should just instantly break, shouldn't it?
It does start to fall apart, yeah.
Because I don't walk through life on rails like a robot.
Yeah.
Relying entirely on one-point perspective seems like it would make a building feel totally static, almost like a staged theater set where you're only allowed to view it from one specific tightly controlled seat.
That's a really sharp observation, and that limitation is the whole reason the system had to evolve. One-point perspective is excellent for what architects call axial views, meaning you are looking straight down the central axis of a symmetrical space.
Yeah.
But it flattens the front surface of whatever you are looking at. If you draw a building facing you in one-point perspective, the front of it is just a flat square. What's fascinating here is that it completely fails to capture the true dynamic nature of human movement.
Because we wander.
Yeah.
We turn our heads. We cross the street diagonally.
Exactly. We are messy. To catch you as you move, architects had to invent a second vanishing point. Because human beings encounter architecture at angles, we need a system that reflects that messy reality. And this brings us to two-point perspective.
Okay, 2-point.
Yeah, two-point perspective is used when you, the viewer, are positioned so that no single face of the object is parallel to your picture plane.
Okay, let's define picture plane really quickly, because that term definitely tripped me up initially.
Oh, for sure. It's a weird term.
Right. So imagine an invisible, totally flat sheet of glass hanging in the air exactly between your eyes and the building you are looking at. That glass is the picture plane.
Perfect way to visualize it.
In one-point perspective, the front of the building is flat and parallel against that glass. But in two-point perspective, the building is rotated. The only thing touching that invisible glass is the leading corner of the building.
Right. You are looking at the object at an angle, so its sides are receding away from you in two completely different directions. You suddenly have two vanishing points, usually placed very far apart on your horizon line.
Here's where it gets really interesting.
Yeah.
Because the difference in how this feels is massive. Think about looking at a flat postcard of a house taken from straight on.
Okay.
You see the front door, the windows, but you have almost no idea how deep the house goes or what its true footprint actually is. That's one point.
Right.
Now imagine walking up the driveway at a sharp 45-degree angle. Suddenly, you see the front of the house and the side of the house simultaneously. You immediately understand the full 3D bulk of the structure.
Yes. Two-point perspective emphasizes what architectural theory calls objecthood.
Object.
Yeah. It treats the building not as a flat billboard or a theater backdrop, but as a tangible, heavy block that you can walk completely around. It emphasizes spatial relationships and directional tension. Psychologically, it feels immensely more natural because it just reflects our lived reality of navigating around obstacles in the physical world.
The mechanics of drawing, it must change completely, though. I mean, I'm guessing if you can't start with a flat square, like in one-point perspective, you have to start with the closest part of the building. Do you just start with, like, a dot in the center of the page?
Not a dot, but a single vertical line. That single vertical line represents the nearest corner of the building, the part that's touching your imaginary glass picture plane. From the top and bottom of that vertical line, you draw your orthogonals, your puppet strings, pulling away toward both vanishing points.
Got it.
So one set of strings pulls off to the left vanishing point, and the other set pulls off to the right.
Oh, I see. So as you add vertical lines further down those receding strings to define the back corners, you are suddenly carving out two faces of the building at the exact same time. You're basically building volume outward from a single edge.
Exactly. Because architecture is fundamentally encountered through movement. When you approach a building on a city block, you don't magically teleport to the dead center of the front door.
No, you walk down the sidewalk.
Right. You see how the building meets the corner of the street. You see its massing, meaning how the heavy, blocky volume of the structure actually sits on the site and relates to the sky. Two-point perspective bridges the gap between the flat abstraction of a top-down floor plan and the complex reality of walking up to a building in real life.
Okay, so we have this incredible geometry now. We have the vanishing points, the horizon lines setting our eye level, the orthogonals acting as strings. They provide the absolute skeleton of the space.
Yes, the skeleton.
But a skeleton isn't a living thing. So how does an architect use this rigid mathematical skeleton to figure out how a room will actually feel to a human being?
That transition from technical geometry to actual human design happens when we use perspective as a testing ground.
A testing ground.
Yeah, architects don't just draw perspectives at the very end of a project to show off a pretty picture to a client. They draw them early and constantly to test the emotional weight of a space. They set the horizon line at 5 feet, map out the room, and ask, does the ceiling feel too low and oppressive?
Oh, wow.
Does this hotel lobby feel expansive and monumental, or just cold and empty? How does a massive concrete wall actually loom over a person walking past it?
It acts almost like a virtual reality simulation, but executed entirely with a pencil.
That is exactly what it is.
And to achieve that simulation, the text points out that architects have to master two completely different approaches that rely on each other: observed perspective and constructed perspective.
Right. Observed perspective is the act of sitting out in the real world, like in a public square or a cafe, and drawing exactly what your eye sees without relying on rulers. By doing this, you learn to notice actual proportions.
You train your eye.
Exactly. You notice how light naturally hits a curved column and how buildings sit naturally in their environment. It trains your intuition.
And constructed perspective is the hard geometry we've been tearing apart today. The rulers, the vanishing points, the exact measurements on a drafting board.
Right. Constructed perspective trains your mind. It teaches you consistent, measurable spatial order. Because observation without structure gets sloppy. Your buildings look like they're melting or falling over.
Right.
But construction without observation becomes totally lifeless and mechanical.
And that lifelessness is a massive trap. The text brings up something that I think completely changes how a drawing feels: composition and tone.
Oh, absolutely.
Because even if your geometry is mathematically flawless, like every single orthogonal perfectly hits the vanishing point,
Yeah.
if all your lines are drawn with the exact same thickness, the drawing looks flat and dead.
It looks like a wireframe.
Yes, line weight matters immensely. You have to draw the edges of things in the foreground darker and thicker, and the edges of walls fading off into the distance lighter and thinner.
And that technique mimics atmospheric perspective.
Right.
Atmospheric perspective is that natural phenomenon where, mountains in the distance look faded, bluish, and less distinct because you are looking through miles of air, dust, and moisture that physically scatter the light.
Wow, yeah.
By using line weight to mimic that effect, you give the drawing graphic judgment. The geometry is the skeleton, but the varying thickness of the lines, the tone, and the shadows, that is what gives the drawing muscle. It subconsciously tells the viewer's eye what is close, what is far, what to focus on, and what to ignore.
Okay, so I'm putting myself in the shoes of someone trying to learn this for the first time, and it sounds incredibly overwhelming.
It's a lot to take in at once.
It is. And the text openly admits that beginners constantly mess this up in very specific ways. A classic mistake is placing the two vanishing points way too close together on the page.
Oh, the funhouse mirror effect.
Exactly. When you do that, the orthogonals converge too sharply, and it severely distorts the room. It makes the building look like it's, warping. Or they get completely bogged down in the tiny details, trying to draw the intricate mullions of a window frame before they have even figured out where their horizon line is.
Rushing to the details is easily the most common pitfall, but the text offers a really vital reminder here. So what does this all mean for someone just trying to sketch? The ultimate goal of perspective drawing is not mechanical perfection or photorealism.
It's not.
No. The goal is spatial understanding. You have to build the big relationships first. You secure your major masses, your overall proportions, and your vanishing points.
You're learning that a cube isn't just a box drawn on paper. It's a heavy volume situated in relation to a human viewer. A long corridor isn't just two parallel lines. It's an emotional sequence of enclosure that literally pulls you forward.
Perspective teaches the absolute deepest lesson of architecture. Space is not just built, it is perceived.
That is so powerful.
Right. The rules of geometry, the horizon lines and vanishing points, are really merely the vehicles we use to understand, manipulate, and anticipate that human perception.
Space is not just built, it is perceived. That entirely reframes the whole concept for me. I mean, we started with Brunelleschi poking a hole in a wooden board to prove that human vision could be mapped mathematically.
Which still blows my mind.
Same. And then we looked at the forceful directed procession of one-point perspective, exploring how staring down a central axis can make a room feel monumental and demanding.
Then we moved into the dynamic realism of two-point perspective, discovering how shifting our view to an angle and tracking two vanishing points reveals the true 3D objecthood and mass of the buildings we navigate every single day.
And we broke down how these strict mathematical rules, combined with the nuances of line weight and atmospheric perspective, allow designers to bridge the gap between abstract top-down floor plans and the lived emotional experience of actually walking through a space.
It's a huge toolkit.
It really is. It is a dense set of rules, but the next time you walk down a long hotel hallway or cross a busy street intersection, look for those invisible strings. Look for those orthogonals pulling your eyes toward the horizon, and realize you are participating in a geometric masterclass just by opening your eyes.
Absolutely. And as you observe those physical spaces around you, consider a broader implication that stretches far beyond the pages of our source text today.
Oh.
Yeah, because we have talked entirely about physical architecture, but think about the digital spaces you spend hours in. Think about three-dimensional video games, highly immersive virtual reality environments, or the sprawling digital landscapes of the metaverse.
Oh, wow. I hadn't even thought of that.
If these mathematical rules of perspective can be used to accurately represent physical buildings and test our emotional reactions to them, consider how the deliberate design of those virtual spaces is secretly utilizing these exact same Renaissance techniques.
That's entirely true.
Right. The programmers and virtual architects building those worlds are actively manipulating your vanishing points, artificially adjusting your digital horizon line, and coding these invisible geometries to dictate your emotions, your sense of scale, and your movement without you ever consciously realizing it.
That is incredible. The magic trick of vision isn't just happening on a sketchpad anymore. It is actively happening on every single screen we interact with.
It's everywhere.